Mechanical energy, Day 4. Current types of energies discussed. Kinetic energy key equals 1, fraction slash 2 mv2. Potential energy, left white lenticular bracket PE, right white lenticular bracket, underscore G equals mgh, left white lenticular bracket PE, right white lenticular bracket, underscore E equals 1, fraction slash 2 Kelvin x2. As we discussed in earlier lessons, the first type of energy we talked about was kinetic energy. As you recall, this type of energy is developed or derived from objects which are in motion. If objects are not in motion, we assume there is no kinetic energy at the moment. Later on we learned about two general types of potential energy. The first type being gravitational potential and the second type being elastic potential. Gravitational potential focuses on the location or height of an object, while elastic potential focuses on objects which has elastic properties. These properties, as you remember, allow the object to stretch or compress. Some examples are rubber bands, bungee cords, springs, coils, bows, and so on. Total potential energy, left white lenticular bracket PE, right white lenticular bracket, underscore G equals mgh, left white lenticular bracket PE, right white lenticular bracket, underscore E equals 1, fraction slash 2 Kelvin x2, left white lenticular bracket PE, right white lenticular bracket, underscore T equals mgh plus 1, fraction slash 2 Kelvin x2. We talk about total potential energy, we combine both gravitational potential and also elastic potential. The units for total potential still continue to be the joule. Mechanical energy, the energy acquired by the objects upon which work is done, is known as mechanical energy. Mechanical energy is the energy that is possessed by an object due to its motion or due to its position. Mechanical energy can be either kinetic energy, energy of motion, or potential energy, stored energy of position. Generally, we combine all the energy that is present for an object, both in the forms of kinetic and potential. Juggling, similar to projectile motion. When jugglers throw the objects into the air, the object is in vertical motion, which means there is kinetic energy and little gravitational potential if we use the location of the hand as the initial point for height. As the ball travels upwards in the air, the energy will be converted from kinetic energy to gravitational potential. At the very top of the trajectory, the object has maximum gravitational potential energy. Then on the way back down to the juggler's hand, the energy is converted from gravitational potential back to kinetic energy. Falling objects. When objects are dropped, they enter into free fall. As you recall, free fall is when an object is falling and has no forces acting upon it itself except for gravity, which attracts the object down, generally to the Earth's surface. If an object is released from an altitude such as 2 meters above ground level, we know that there is gravitational potential energy stored in the object. Once released, the gravitational potential is then converted into kinetic energy. There it will continue to be gravitational potential energy until the height of the object reaches 0. Falling objects with inclines, slopes. When an object falls down a hill, if some sort of a slope is involved, we generally disregard the slope due to the fact we do not lose energy to the slope. The only factor that the slope may affect would be diverting the object to a different general direction. This is commonly seen in roller coasters. The track of a roller coaster diverts the carts upwards once more instead of allowing the car to go straight towards the ground. Roller coaster, as previously discussed. Roller coasters, we have a transfer of a strong amount of gravitational potential energy into kinetic energy. As we view on the graph to the right, at location A, the cart has maximum potential energy. At the moment the cart is moving quite slow. Once the cart goes down the first hill, there is a transfer from gravitational potential into kinetic energy. By the time the cart reaches location D, it is located at half of the height and we have equal values of gravitational and kinetic energies. Skiing, as stated before with slopes, we assume the slope will not take away any energy. If the skier begins with 100 joules of potential energy and begins to move downhill, by the time the skier makes it halfway down the hill, have 50 joules of kinetic energy and 50 joules of gravitational energy, until the skier is located at the bottom of the hill and reaches maximum kinetic energy and moves the fastest at this part due to a depletion of gravitational potential energy. Pendulum motion. A pendulum as pictured on this small clock contains a pendulum. The motion of the pendulum generally swings back and forth from left to right. On the diagram shown to the right, the pendulum is lifted from its resting place, which is location C. Due to the fact that the pendulum is at a height, it contains potential energy. Once it begins to travel downward, there is a conversion of potential to kinetic energy until it reaches the bottom and obtains maximum kinetic energy and with its velocity. Then on the way to the right, we see a transfer from kinetic to potential once more. The transfer of energy will be continuous, as the motion will continue to go from right to left and vice versa. Mechanical energy. Me equals key plus, left white lenticular bracket, PE, right white lenticular bracket underscore G plus, left white lenticular bracket, PE, right white lenticular bracket underscore E, left white lenticular bracket, PE, right white lenticular bracket, underscore G equals M, GH, left white lenticular bracket, PE, right white lenticular bracket, underscore E equals 1, fraction slash 2 Kelvin x2 key equals 1, fraction slash 2 MV2. Mechanical energy will combine the three forms of energy that we have already discussed, both type of potential and also kinetic. Here we have a general structure of mechanical energy and its components in their original forms. Equation. Me equals 1, fraction slash 2 MV2 plus MGH plus 1, fraction slash 2 Kelvin x2. This is the complete and expanded equation for mechanical energy. The first set of parentheses contains the components for kinetic energy. The second set of parentheses contains gravitational potential, while the final set contains elastic potential.